So at the top of the page one, I have my word problem solving strategy. Mathematics is very visual. Okay? So, I mean, I guess there are like two things that are very important in succeeding in mathematics, in my opinion. One is to know the rules, PEMDAS and right order of operations and all this stuff. Okay? And the other one is visualization. Right? If you can visualize a problem up here in your mind, it makes math a whole lot easier. Okay? And so, in solving these problems, the first step in my word problem solving strategy is draw a good picture. Okay? A good picture of the problem. Right? That's the visualization part. Then we're going to define the variables. Right? What does X mean? What does Y mean? So forth. Okay? And then we're going to set up the equation that describes the problem of interest, right? What we're trying to find, what we're trying to solve. And step number 4 then is once you have the equation set up, solve the equation, right? Solving the equation, you solve the problem. We're going to do 1, 2, and 3, okay? We're not going to do 4, okay? So our focus is on setting up the equation that describes the problem of interest, okay? So let's take a look at example number 1. It says a rectangle has area 16 meters squared. Express the perimeter of the rectangle as a function of the length of one of its sides. What is the domain of this function? Okay. So express the perimeter of the rectangle as a function of the length of one of its sides. So step number 1, draw a good picture. So let's draw a rectangle. That's what the problem's all about. Okay. And this rectangle has an area equal to 16 meters squared. Okay. Now there are many rectangles that have an area 16 meters squared, but they don't all have the same length and height. Okay. So we're going to let X represent the height of our rectangle and Y represent the length. Okay. So now we're defining the variables. X is equal to the height of the rectangle, right, in meters, and Y is equal to the length of the rectangle in meters. Now, in all these problems, right, we're going to set up an equation, right, in the variables X and Y. And in all these problems, there is some kind of constraint that allows us to write one variable in terms of the other, as a function of the other, okay? And in this case, the constraint is the area is fixed at 16 meters squared. So you know that height times length is equal to area, right? Some will say width times length, right, whatever. Okay. Well, height in this case is X, the length is Y, and the area is fixed at 16 meters squared. Okay. So X times Y equals 16 is our constraint, right? This is the area constraint. And now I have an equation in X and Y. I can solve for one of the variables, right? So since we're going to write the perimeter as a function of X, okay? Well, it says one of the variables, but I'm picking X, okay? I'm going to solve this equation for Y, and we get Y is equal to 16 over X, okay? So whatever the height is, right, the length is equal to 16 divided by the width, okay? Because this area is fixed at 16 meters squared. Okay? Can't be anything other than that. Okay. All right. So if the height of the rectangle is x, right, the length of this side is x, then you know this length of this side is x, and the length of this side is y. So the perimeter, what's the definition of perimeter?
Sum of the length of sides.
Yeah, it's the distance around the rectangle, right? So if you were running, right, this path, right, is the distance around the rectangle, right? And so the perimeter in this case is x plus y plus x plus y. And so when you combine like terms, right, the perimeter is 2x plus 2y. Okay? You got two sides of length x and two sides of length y. Okay? Now, if I replace y with 16 over x, and now I have the perimeter as a function of x only, right? Now it's it's a function of x and y, but if I replace y with 16 over x, I have the perimeter as a function of x only. So for my function notation, I'm going to use p of x, p for perimeter. Perimeter is a function of x, and it's equal to 2x plus 2 times y, which is constrained to equal 16 over x. Okay? And now when I simplify that, okay, 2 can be written as 2 over 1. And when you multiply those two quotients, you get the perimeter as a function of x is equal to 2x plus 32 over x. So the perimeter, right, remember area is fixed at 16 meters squared. So the perimeter, okay, can be written as a function of the height x. Okay? Whatever the height is, okay, we can determine what the perimeter is around this rectangle with a fixed area of 16 meters squared. Okay? What is the domain of this function? Okay. Well, the height can't be negative, and the height can't be 0, because if the height is 0, you don't have a rectangle. Okay? So the domain is x can't be negative and it can't be 0, so it's got to be greater than 0. Right? And it's actually can be any real number greater than 0. It can be 1,000,000, because if x is equal to 1,000,000, then y is equal to 16 divided by 1,000,000, right? And x times y still equals 16 meters squared. Okay? So the domain is all real numbers greater than 0, which in interval notation, right, is 0 to infinity. Okay? So just to prove the point, okay, if x, I'll do it over here. If x is equal to 1,000,000, right? That's the height of the rectangle, right? So if the height of the rectangle is 1,000,000 meters, then the length of the rectangle is 16 divided by 1,000,000 meters, right? So that means we've got a really tall rectangle, but it's not very wide at the bottom, right? It's really thin. And that product is still equal to 16 meters squared. Okay? So it doesn't matter. X can be any real number greater than 0. Okay. Any questions on that, ladies and gentlemen? All right, in example 2, we're kind of doing the opposite. Now we have a rectangle with a perimeter of 20 meters, And we're going to express the area of the rectangle as a function of the length of one of its sides and what is its domain. Okay. So again, we draw a good picture, which is a rectangle. Okay. And instead of calling x the height, I called it the width in this problem. Doesn't matter. So the perimeter in this case, right, the distance around the rectangle is fixed at 20 meters. Okay. Express the area of the rectangle as a function of the length of one of its sides. Well, we have a perimeter constraint, right? Whatever the values of x and y are, right, the sum of the four sides has to equal 20 meters. So from the previous problem, we know that 2x plus 2y is equal to the perimeter of the rectangle. And the perimeter again is fixed at 20 meters. So this is our perimeter constraint. And now we can solve for y, right? We can write the length in terms of the width x. And so we'll move the 2x to the right-hand side by subtraction. We have 2y is equal to 20 minus 2x. And now when you divide both sides by 2, you get y is equal to 10 minus x. Remember, I got to divide each of these terms by 2. Because division does not undo subtraction. So 20 divided by 2 is 10, and 2x divided by 2 is x. So whatever the width is, right, the length is automatically determined by this equation. Okay. All right, so now we got to write the area, right, as a function of x. So we have area, right, because that's what we're doing. We're going to express the area of the rectangle as a function of the length of one of its sides, and I'm using x. So area, you know, is width times length. And the width is x, the length is y. So the area of our rectangle is x times y. And now if I replace y with 10 minus x, I can write the area as a function of x. So I use capital A to represent area. And so A of x is equal to x times 10 minus x. So that's the area as a function of one of its sides, in this case the width x. Okay. Now the domain, like last time, okay, the width can't be negative and it can't be 0. Because if x is equal to 0, you got 0 times 10, which is 0, no area. Right? So the width has got to have some height, right? It can't be 0, it can't be negative. So x has to be greater than 0. Okay. But there's a limit to how big x can be. If x is equal to 10, right? Then the area is 0 again, because if the height is 10, then the length, or if the width is 10, then the length is 0. You can't have 0 length, right? And x can't be greater than 10, right? X can't be 11, because then you got 10 minus 11, which is negative, and you can't have negative area. So the width x has to be between 0 and 10. Okay? It's got to be greater than 0, and it's got to be less than 10. Okay? For this to make sense. Okay? And so in interval notation, we have parentheses, 0, comma, 10. Now, let me give you a hint. In the previous 2 semesters, maybe 3, I've had given a quiz, and I've told the students, the quiz is going to be these 2 problems with different numbers. And they still get it wrong. I don't know how. It must not study. I don't know how. Right? And so I'm telling you now, when we have this quiz, which won't be the Wednesday when we come back, it'll be the Wednesday after that. The quiz is going to be on these 2 problems with different numbers. Okay? So you got what, 3 weeks, right, to memorize it. Okay? All right, so let's flip over to something a little more interesting. Okay? And these next 2 problems are actually our old final exam questions. And so I've done the visualization for you in these next 2 problems. Okay? A closed rectangular box with a square base x and height h must have a volume of 100 inches, 100 cubic inches. Okay? 100 inches cubed, 100 cubic inches. Express the surface area of the box as a function of the length x of the base of the box. Okay? So here's our box, right? It's got a bottom, it's got a top, 4 sides. Okay? So the length or the width of the base, the 4 sides of the base and the 4 sides of the top are x inches. Okay? The height of the box, so the box isn't a cube, right? It's rectangular. The height of each side of the box is 8 inches. Okay? So we got square top, square bottom, and then a height of 8 inches. Okay? Express the surface area of the box as a function of length x of the base of the box. Okay? So x is the width of the box, and h is the height of the box. So we have a volume constraint of 100 cubic inches. Okay. So we'll use that, right, to express h in terms of x. Okay. So volume, in this case, is width times height. Usually we would say width times length times height if the box had a rectangular bottom. Okay. But it's a square base. So the length is equal to the width. Okay. So we have width times height is equal to the volume. is X, the height is H, and the volume is fixed at 100 cubic inches. So we have the equation X squared times H is equal to 100. That's our area constraint.
I have a question.
Yes, ma'am.
What do you mean by area constraint?
Oh, you know what? I wrote down the wrong word. Thank you very much. It's Mallory, right?
Yeah.
I wrote down the wrong word. Thank you for saying something. Yeah, so that's our volume constraint, okay? So we have an equation in two variables, X and H, and we can solve for H, right? And so the height H of the box is constrained to equal 100 divided by the width squared. Okay? So whatever the width is, okay, whatever the width is, X, the height H is constrained to equal 100 over X squared.
So the volume constraint is like the I don't really understand.
Yeah, we need a constraint so that we can express one variable in terms of the other. Otherwise, right, there's nothing to solve.
So it's
Okay.
basically like X squared times by H gives you the volume. Okay.
Yes.
Okay.
Yeah. So, right, so this up here, right, is X times H is equal to volume. Okay. But the volume is fixed at 100. Okay. All right. Now we gotta express it. The surface area of the box is a function of length X at the base of the box. Okay. Well, the total surface area of the box is equal to the area of the base plus the area of the top of the box, right? There's 6 sides to this box, right? There's a bottom, there's a top, and 4 sides. So the total surface area is the area of the base plus the area of the top of the box plus the area of the 4 sides. Well, what's the area of the bottom of the box?
X squared.
X squared, right? The bottom of the box is X by X, right? So both, we have a square base and bottom I use interchangeably, right? Alright, so this is what the base, bottom, and the top of the box look like, right? They're square. The width is X inches. So the area of the base and area of the top are both X squared inches, right? Now, each side, okay, has a height of H. There's a height of H and a width of X, right? So what's the area of one side? X times H, right?
Can you explain the 2x squared?
We have, the box has a square bottom, square base. And the side, each side is like X, right? So the area of a square is which is x times x, x squared,
That's for the top and the bottom.
and the bottom, okay? Yep. Both the bottom and the top are squared, okay? The sides are rectangular shaped, okay?
So there be two of those?
Yes. Yeah, so that's why I have area base plus area of top,
Oh, okay.
okay? So I could use the word bottom. Okay. But on this final exam question, they use the word base, so I'm going along with it, okay? So the area of the bottom of the box is x squared. The area of the top of the box is x squared, okay? So you got square bottom, square top. So you got to visualize. Now I gave you a picture. It also helps to visualize it in your mind, okay? I'm sure you guys have seen boxes before, okay? Lowe's, whatever. All right. Now each side is a rectangle, right? It's height h, width x, right? So surface area of one side, right, is the area of a rectangle. So it's x times h, right, is the area of one side. But how many sides are there? 4. So we got 4 sides of x times h. So that's the area of the 4 sides, right? You add x times h 4 times, you get 4 times xh, right? Well, now if I replace h with 100 over x squared, I can express the total surface area as a function of x, right? So I'm going to use capital S for surface area. And so my total surface area is a function of x, okay? X squared plus x squared is 2x squared. And now I substitute for h. H is equal to 100 over x squared. And now it's, right, total surface area is a function of x now, only. And now it's just a matter of simplifying this product down here, okay? So the total surface area as a function of x is equal to 2x squared plus, now 4x can be written out as 4x divided by 1. And so 4 times 100 is 400. And this x cancels one of those x's, x over, right? And I just left with x in the denominator. Any questions on that? So whatever the width of the top and the bottom of the box is, right? The total surface area for all 6 sides of the box, right, is equal to this, to the right hand side here, right? Once you plug in for x. And that's the total surface area with this volume constraint of 100 cubic inches. Okay. Any questions on that, ladies and gentlemen? All right, example 4. In example 4, you're given the surface area, and you got to write the volume as a function of x. Okay. So again, we have a square base, and the height of one side is h. What's different in this case is we don't have a closed top, we have an open top. You see where it says open? There's no top on this box. So there's only 5 sides to this box, the bottom and the 4 sides. Okay. So the height of the box, okay, on all 4 sides, right, is 8 inches. But the base is square. So again, we're going to let x is equal to the width, and we're going to let h is equal to the height. So we're given the total surface area, so that's our constraint. And so we have the area of the base plus the area of 4 sides is equal to the total surface area. Well, what's the area of the base? So that we gotta erase top over here, okay? Because we have an open top. What's the area of the base? The bottom of the box. Yeah, it's x squared still, right? This was what the base or the bottom looks like. And what's the area of one side of the box? H times x or x times h. And how many sides are there?
4.
So it's going to be 4 times x times h, right? You add up x times h 4 times, you get 4 times x times h, right? And then the total surface area is equal to 50 square inches. So this is our surface area constraint. So we have an equation in 2 variables. We can solve for h, right? So we move the x squared to the right-hand side via subtraction. And now we divide both sides by 4x. We isolate h on the left-hand side. So whatever the width x is, the height is constrained to equal this, right? Whatever number you put in for x, the width, this is how you get the height from that equation. Well, we got to express the volume of the box as a function of x. So you know volume in this case is equal to width times width times height. Well, width is x. And the height, h, right, is, well, let's do it steps. So it's x times h. So this is equal to, volume is equal to x squared times h. And now if I replace h with this on the right-hand side, I can write the volume as a function of x. So I have the volume as a function of x is equal to x squared times h, which is 50 minus x squared over 4x. So that's the volume as a function of x, okay? But you're told to simplify your answer, okay? So this is, you know, if you stopped right here on the final exam question, you would get credit up to here. You'd probably lose a point or two if you didn't simplify. Okay? So this is, remember, x squared is like x squared over 1. So when you multiply numerators, you have x squared times 50 minus x squared all over 4x. Well, one of the x's in x squared cancels this x, right? Because they're common, right? They're factors in the numerator and denominator. And we're left with x times 50 minus x squared over 4. Write it over here. And so we have the volume as a function of x, okay? So I distribute the x inside the parentheses, and I have 50x minus x cubed over 4. And so then when I divide each of these terms by 4, 50 divided by 4 simplifies to 25 halves times x. Actually, I'm going to write it down here. And we have minus x cubed divided by 4, or minus 1/4 times x cubed. That was the final answer, right? Simplified on the final exam. If you went that far, you got the extra point. Cool beans. So I haven't released the WebAssign homework yet, but I'll get it probably done today. And it'll be due to second class after spring break. So we have our long day on Thursday, right? So probably it'll be due Wednesday when we come back from spring break. Okay. So let me take attendance, and then we'll get a jump on spring break.